So welcome to experiment L4, where we're going to find the focal length of a convex lens. We've done something very similar before in L1 where we found the focal length of a concave mirror. So we're going to use exactly the same technique here. As well as that, when I explain this, I'm going to be using an exam question. I'm going to use exam question 2012, question 2. Now, where will we find this in our notes? Well, go to your notes and you want to go to lesson number 5, refraction 2. And scroll down towards the end of here. We will have the experiment itself. So here's my experiment, experiment L4, where you've got a convex lens placed between a light source and a screen. So the question I'm going to do is Leaving Cert 2012, experiment L4. So let's go through it. So it says in an experiment to measure the focal length of a converging lens. You know that a converging lens is also called a convex lens. The student measured the image distance V, and for each of 4 different values of the object distance U. The table shows the data recorded by the student. So you've got values of U. So when U is 12, V is 64 centimeters from the lens. The first thing they're asking me for 15 marks is to describe, with the aid of a label diagram, how the student obtained the data. Well, first thing is, let's draw our label diagram. And of course, all my label diagrams are very, very simple. I mean, I can't draw, so I'm just using rectangles and so on. So this particular piece of equipment here is called the optical bench. Nothing fancy about it. It's just a bench where you can slide your lenses and your screens up and down. And it's got a meter stick embedded into it. So in the middle of that optical bench, I'm going to put in our convex lens. As the object, I'm going to use our light source. So let's place my light source here to the left of it. So the light source, the filament inside the bulb there will represent your object O. So this here is my light source. So the light will go through the converging lens. And if I want to capture the image of the object, then I'm going to place a screen on the far side. There's my screen, which is just a white board. And the screen is where the image I will be formed. Sometimes they ask me, sometimes they don't, but I always do it anyway. I write in U and V. So U is the object distance from the object to the lens, and that's U. And V, that's the image distance from the screen where the image is to the lens, and we call that V. So in the question, they're asking you also to describe how the student obtained the data. Now, it's important that you look at the words carefully. So they're saying, describe how the student obtained the data. So we're talking about how did we find U and how did we find V? That's all you have to describe. So in terms of finding U, you will say, place an object a certain distance from the lens, move the screen until a sharp image of the object is formed, measure V. Change U, measure V again. So the solutions for that are written down in your solutions section of your notes. But that's what they're asking you. How did you obtain the data? Don't start talking about how did I put everything together and so on. So always read the question very, very carefully. So moving on in my question. They're asking you the question, why is it difficult to measure the image distance correctly? Or accurately, should I say? Well, I suppose you're trying to get a sharp image, and you might have 2 students doing the experiment. One student thinks that's sharp, the other thinks it's not so sharp. So trying to obtain that sharp image, that there's a great difficulty in that. So 4 marks for that. Next part says, using all of the data in the table, find a value for the focal length of the lens. Now, I said to you before that there are 2 ways to do this. You can do this by calculation, using your calculator, or you could do it by graph. Now, they don't ask you how to do it, then I will definitely do it using my calculator. So there's the data from the exam question. Here's your formula. 1 over u plus 1 over v is equal to 1 over f. And I want to write that formula down in terms of f. So turn the 1 over f upside down, and I get f. Now, I can't turn each of those upside down because of the plus in between them. So I'm going to turn the entire thing upside down like this, wrap them in brackets, and the way you turn it upside down is get the reciprocal of them. That's to the power of minus 1. So I'm going to use each pair of values to find my different focal lengths. So I'm going to find f1. I'm going to replace u by 12 and v by 64. So I get 1 over 12 plus 1 over 64 to the power of minus 1. Well, let me show you that first one. I'll just do the first one with you on the calculator, just to show you the technique. We're going over to our board here. I want to get my calculator. So, bracket, fraction, 1 over 12 plus fraction 1 over 64, close bracket, and I want to go to the power of minus 1. So if I press shift on this button here, I get to the power of minus 1. I go to execute, equals, I get a fraction. I want it in a decimal, probably 2 decimal places, because it's not my final answer. So I'll go format, I'll go down to decimal, execute, and I'll get, say, 10.105, say 10.11, 2 decimal places. So I get 10.11 centimeters. Now you go ahead and do the rest of them. They're all done in your solutions. So find your value of f2. 1 over u, 1 over 18, plus 1 over v, 1 over 22.1, the power of minus 1. I'm going to put that into my calculator. I'm not going to show you how to do that one. I've got the answers here. I get 9.92. You do them with me. Then I'm going to get f3. So my third pair of values is going to be 1 over 23.6 plus 1 over 17.9, power of minus 1. You put that into your calculation to 2 decimal places, and I get 10.18 centimeters. Then to the final pair of values, f4. So f4 is 1 over 30 plus 1 over 15.4, the power of minus 1. And I get an answer of 10.18 centimeters. You've got 4 values for f, and of course they should all be the same. So the obvious thing to do at that point then is you're going to get the average value of all the f's. You're going to add together your 10.11 plus 9.92 plus 10.18 plus 10.18. You divide that by 4 for the 4 values, and I will get an average value. You can go to 1 decimal place now of 10.1 centimeters. So that way, you see, I've used all of the data in order to get my focal length. That's important, that every pair of values is used. Right, let's go back to the question. So the last part they're asking me for 6 marks. So there was 15 marks for the previous part. For 6 marks, why is it difficult to measure the image distance when the object distance is less than 10 centimeters? So you probably know the answer to this. We've actually dealt with it before. I mean, you've got a focal length of 10 centimeters. So if the object distance is less than 10, what does that mean? It means you're inside the focus. And what happens when you're inside the focus? Well, you're going to get virtual images that cannot be formed on screens. So you can't see the image when it's inside the focus. It just can't be formed on a screen. Okay, so that's the end of that question and the end of that experiment.